Hello. Today we're going to be doing systems of equations applications, and we are going to solve some application questions. So let's begin. Alright, so Pyramid Staples charges $20 per hour, including insurance for trail rides. Sarah Staples charges $16 per hour with a separate insurance fee of $12 per ride. Suppose C dollars is the cost of a trail ride lasting 8 hours. The equations relating to cost to hours for each staple are C equals 20H and C equals 16H plus 12. How many hours must a trail ride last for the cost to be the same for each staple? And then we have right there for statement. So a trail ride will last 3 hours for the cost to be the same for each staple. Suppose you wish to ride for 2 hours. Which staple would you choose and explain? Okay, so the cost of a 2-hour ride with Pyramid Staples is $40. The cost of a 2-hour ride with Sarah's Staples is $44. I would choose Pyramid Staples as I calculate the result for a 2-hour ride is $4 cheaper compared to its competitor. So we substitute input of 2 for variable h, output of cost is calculated result. So okay, so suppose you wish to ride for 2 hours, which staple would you choose? So we calculated Pyramid Staples and Sarah's Staples cost for a 2-hour ride, and we inputted a value of 2 for h, so h being 2 hours, and then we substitute it into each equation that is a representation of how much it is to cost per ride. And Pyramid Staples is $4 cheaper for a ride that lasts 2 hours. The cost of a 2-hour ride with Pyramid Staples is $40. The cost of a 2-hour ride with Sarah Staples is $44. And then we did some subtraction here. And we found the difference in cost per 2-hour ride. Meaning Sarah Staples is $4 more expensive than Pyramid Staples, leading me to choose Pyramid Staples for a 2-hour ride. Alright, on to the next question. A part-time sales clerk at Gen X Stereo Store are offered two methods of payment. The first method is $1,500 per month with a commission of 4% on total sales. The second method is $1,700 per month with a 2% commission on total sales. Let X represent the total sales, and let Y represent the total earnings for part-time clerks. A linear system that represents this situation is payment method 1 and payment method 2. For payment method 1, it's Y equals $1,500. 1,500 plus 0.04x, and for the second payment method, it's Y equals 1,700 plus 0.02x. Write to explain each equation. So this equation represents the first method of payment. For part-time sales clerk. With the base pay of $1,500 and per month with a 4% commission on total sales. $1,500 is base pay, 0.04x, 4% commission, and Y equals total earnings Okay, and 2y equals 1,700 plus 0.02x. This equation represents the second method of payment. For part-time clerks, with a base pay of $1,700 and a 2% commission on total sales. And Y being total earnings. Solve the linear system by substitution. So we have y equals 1,500 plus 0.04x, and then equation 2, which is y equals 1,700 plus 0.02x. And then we set each equation to equal each other. So we're going to substitute x equals 10,000 into equations 1 or 2. And if you add input that into your calculator, you should get about 1,900. So the point of intersection is 10,000, 1,900, meaning regardless of which payment method you'll get paid the equal amount. so we solved it. So the solution represents the point of intersection, meaning when sold 10,000 units of stereos, regardless of which payment method you selected, the part-time clerk or employee will be paid $1,900. It's the point where the two functions intersect. Both employees will be paid the same amount. Both employees will be paid the same amount. $10,000 in revenue, $1,900 in employee payment. For both methods. What total sales revenue would result in equal total earnings from each plan? So we have our point of intersection, which is 10,000 and 1,900, x, y. So 10,000 in sales revenue would result in equal pay for both methods. the equal pay being $1,900 per month. I'm just going to rewrite it just so it's a bit neater. Which plan is better for a person with a total monthly sales are $20,000? Explain. So we have y equals 1,500 plus 0.04x. Y equals 1,700 plus 0.02x. Payment method. One. Y equals 1,500 plus 0.04, $20,000. Y equals 2,300. Payment method 2. Y equals 1,700 plus 0.02x. X being $20,000. Okay. So we did some subtraction here. The total earnings in plan 1 and the total earnings in plan 2, and the results to the total difference in earnings to plan 1 compared to plan 2. And let's do a therefore statement. Plan 1 is the better plan to go with for a person whose total monthly sales are $20,000, as it has a $200 increase compared to Plan 2. The 4% commission gives the employee $200 extra, and that's the equation to go with for Plan 1. In hockey, the number of points a player scores is equal to the sum of her or his goals and assists. In the 1998 and 1999 NHL season, Matt Sundin scored 83 points. He scored 21 fewer goals than assists. A linear system that represents this situation is number 1 being x plus y equals 83, and number 2, x minus y equals 21. So we have 1, x plus y equals 83, x being assists, y being goals. This equation summarizes the amount of goals and assists for his final score of 83. And then we have equation 2, x minus y equals 21. This equation summarizes that he scored 21 fewer goals than assists. Solved the linear system, so we have 1 x plus y equals 83, and then we have 2 x minus y equals 21. Subtract them. 0x plus 2y equals 62. 31. Meaning he scored 31 goals. This is solving by eliminations. The previous one were substitution. we substituted, first we did process by elimination, and we eliminated the x variable to find the y value of y, and then we substituted that value of y, or the y coordinate of the POI, and we substituted it into equation 1, and then we followed the order of operations to get the value of x. And as we figured out in part A, is that x is our assists and y are our goals, meaning he scored 31 goals and 52 assists. Explain what the solution represents. Okay. So with using the elimination, we figured out that Matt Sundin has scored 31 goals and 52 assists in his final score of 83 in the NHL 1998-99 season. And that's all I have for you today, and thank you very much and have a great day.